stays out in front. How do you differentiate the natural log of some stuff? 1 over the stuff times the derivative of the stuff, okay? Don't forget to take the derivative of the inside. Even if it is something as simple as 1, you leave it off one time, you're going to leave it off the rest, okay? Then, plus, now go to the next term. What's the derivative of 1/2 ln of cosine of x?
1/2 cosine x, 1 over cosine x. Times negative sine x.
Very good. Last one. Negative 1/2 ln of 2x minus 1. What's its derivative? Times what? 2. There it is. Doesn't look very nice, but it is derivative. Okay, in one of its many, many forms. You can clean this up a little bit in that here the 2's cancel. And what's sine over cosine? Tangent. This is 1 over 2 times x plus 1 plus 1/2, nope, minus 1/2 the tangent of x minus what? 1 over, oh, what cancel? Ooh, yeah, nice try, huh? How close are they? Yeah, what's different? That 2. The 2 would make it 2x plus 2 on the first term, but 2x minus 1 on the last one. So we're good. That is it. There's your derivative, nice and clean. Okay? You would get the same answer, if you believe me, doing this derivative. Okay? But it would look really different because this would end up being a chain rule within a chain rule within a chain rule with some products and quotients in there. And what happens is this is actually all one term. That's 3 terms. In order to make the derivative of this look like that, you'd have to find a common denominator and bring all of it together as one mess. Okay? So there's your derivative. If you've got a function where you have the log of some stuff, remember these rules. They actually come in handy. This is why we want you to know your algebra before you take your calculus, because they make things very, very nice. Okay? Now, another way that they make things nice is if I give you this function and ask you to differentiate it. No. Yes, this is the one I wanted. What would you have to use to differentiate that then? Quotient rule and product rule, but it's the product rule of how many functions? 3 of them. Could I make this easier on myself? By doing what? Remember, it's an equation. Yeah, take the log of both sides. Since it's an equation, as long as I do the log of both sides, I'm not altering it any. So I'm going to take the natural log of y and the natural log of this. They're the same thing, okay? Only now, in order to do the derivative, you actually have to do it how? Because where's your y at? It's inside of the log, which means you have to use what? And what did we do yesterday? It was a form of chain rule. It was specifically called what? Implicit differentiation. okay? But before we do that, why would I care about the fact that it's the log of that stuff? I have the log of a nasty fraction and some products. So can I rewrite it further?
Yes.
ln of y is equal to what? ln of 1 minus ln of t. Okay, I'll do it. Plus ln of what? T minus 1, keep going. Do you agree? I don't agree.
No.
Why?
You carry the minus sign through.
Remember, any factor that's in the denominator of a logarithm has what in front of its sign of its log? Has what sign in front? Has to have a negative in front of it. Okay?
It's like
So-
it's in parentheses.
I was gonna say,
Yes.
you could have,
Yeah, we could have bracketed it, but I don't want to do that. I mean, because then I would have to distribute it eventually. So we'll just do that. What's the natural log of 0? Or what's the natural log of 1? 0. That term's gone. Don't need it anymore. Now, what is the natural log of y? What's the derivative of the natural log of y with respect to x? How'd I get that?
why?
Y is some function of x, well, some function of t. That function is actually this thing, okay? But we rewrote it so that the derivative was a lot nicer to work with. So I have to do it implicitly, which means that I do the derivative of the outside, which is 1 over y, times the derivative of the inside, which is my y prime, okay? Equals, what's the derivative of negative ln of t? Negative 1 over t. What's the derivative for the negative natural log of t minus 1? Negative 1 over t minus 1, and the derivative of the inside? 1. I picked some nice ones, didn't I? Minus, what about the third one back there?
1 over t plus 2.
1 over t plus 2. Okay? Now, we can't leave it like this because why?
Because
Y prime isn't by itself. So what do you have to do to solve for y prime? Or
Multiply by y.
multiply both sides by y. And what is y again?
top function.
That nasty top thing. So what is the derivative of this? Negative 1 over t minus 1 over t minus 1 minus 1 over t plus 2 times 1 over the original function all the way over there. And there's my derivative. A form of it, okay? There's a form of the derivative. It doesn't have to be, it's the same thing you would get if you did the quotient rule or the product rule, however you were looking at thinking of doing that particular problem. What we could do is to go through and find the LCD and clean that up. But really, no reason to. That's just nice for what we're doing now. Okay? So those logarithms can actually help us take the derivative of some crazy functions. These three properties right here are going to help us take derivatives if we can remember those logs. So in your homework, just so you know, when they say, oh, what does it say? I can't remember off the top of my head. Use the logarithmic differentiation. Use logarithmic differentiation to find the derivative of y. They're talking about doing what we did on this last problem. So starting with 41, they want you to do this to it because they are really nasty products and quotients that involved trig and quotients and products and all kinds of nasty roots. So if you do the problems that I assigned in those section with the directions that say use logarithmic differentiation, this is what they're referring to. Take the log of both sides and differentiate it that way. Okay? In other words, use your algebra first, and it'll make your life a lot easier. Maybe. I don't know. It all depends. Okay? All right.